Thanks to the Great Courses Plus for supporting PBS. They say that a watched pot never boils. This has now been proven true by quantum mechanics. A moving arrow is at rest. This is obviously a nonsensical contradiction, but Zeno, Greek philosopher famous for his metaphysical trolling, devised a paradox whose conclusion is just this. Here's how it goes. If you look at an arrow flying through the air at any instantaneous snapshot in time, the arrow doesn't travel any distance. If time is composed of an infinite number of these snapshots, and the arrow doesn't move in any of them, then the arrow is at rest during the entirety of its flight. The moving arrow is at rest. Nowadays, most physicists and mathematicians don't really see Zeno's arrow as paradoxical. We think of an instant as a vanishingly small interval of time, then during that time, the moving arrow travels a vanishingly small distance. But the vanishingly small part cancels out, and the arrow's instantaneous velocity is very real. That's what a mathematician might tell you. But quantum mechanics also has a thing or two to say about extremely tiny distances and time intervals. In fact, if we're talking about a quantum arrow, there may be a way to freeze its motion simply by looking at it, through the aptly named Quantum Zeno Effect. The Quantum Zeno Effect predicts that certain quantum events, like the electrons moving between atomic energy levels or the decay of atomic nuclei, can be frozen through the simple act of observation. I'm going to tell you about some very real experiments that claim to have demonstrated this phenomenon. But first, let's see if the Quantum Zeno Effect can save us from being shot by a quantum arrow.